Hey everyone, and welcome! Today we're getting our hands dirty with one of the most exciting concepts in AI right now, Retrieval-augmented generation, or RAG, as you'll hear called. We are going to build an app that makes AI way smarter by teaching it to use your own data. And we'll do it all inside the Databricks ecosystem. So let's jump right in and build this thing step by step.
So here's the plan for our journey today. First, we'll cover the why. Why is RAG on Databricks such a big deal? Then, we're going to walk through building our app piece by piece. We'll start with getting the data in, then making it searchable, and finally, actually generating those smart answers. After that, we'll see how to level up with some pro techniques before we zoom out and look at the whole life cycle of a RAG app.
So, what is the big deal with RAG? Well, imagine this. Instead of a generic AI that knows a little about everything, you're building a total specialist. Think of it like a smart librarian who's read every single document, every memo, every email inside your company. That's exactly what RAG lets you build. It forces the AI to base its answers on the facts and the context of your world.
Okay, so here's the official definition. But what does that really mean? In simple terms, RAG is a technique that gives a large language model an open book test. Instead of just relying on whatever it learned during its initial training, the model first gets to look up the relevant facts from your documents. Then it uses that specific context to put together a much smarter, way more accurate response.
And honestly, this is a total game changer. Why? Because RAG solves some of the biggest headaches we have with LLMs. It means you can let the model use your company's private data and do it securely. You can keep it totally up to date with information that's changing every day. And, this is huge, you can make it cite its sources. That means no more AI hallucinations or made-up answers. You can actually check its work and see exactly where the information came from.
All right, let's get building. Step 1 is the foundation for everything. We have to inject our data. Before our AI librarian can answer any questions, we've got to stock the library. This is all about getting our raw data, our documents, PDFs, you name it, into the Databricks Lakehouse. This is the bedrock for everything else we're going to do.
Now, inside Databricks, you've got a few options for where this data can live. You could upload files right to the workspace, use DBFS, or connect to something like Azure Data Lake Storage. But the modern way, and the one we really recommend, is using Unity Catalog volumes. Think of them as a centralized, governed place for all your files. The best part, you can apply fine-grained security and access controls to your documents, just like you would with a regular data table. For any serious enterprise-level app, that is absolutely essential.
So what we're really doing here is a classic data engineering task, ETL. It's pretty simple. We extract the raw documents from wherever they are. We transform them, which usually means cleaning them up, stripping out weird HTML tags or headers. And then we load that clean text into Databricks, getting it ready for our AI.
Okay, our data is loaded. So now we're on to step 2, creating the actual knowledge base. And look, this is about more than just storing data. It's about making it searchable, instantly searchable. We're basically creating a hyper-efficient digital card catalog for our AI librarian so it can find the perfect piece of information in the blink of an eye.
This whole indexing process, which you'll often use a library like LangChain for, really boils down to 3 key stages. First, we load the documents we just cleaned up. Next, and this is super important, we split them into smaller chunks because you can't just stuff a 100-page PDF into an LLM. And finally, we store these chunks in a special kind of database called a vector store. This thing is cool because it organizes the data based on its semantic meaning, not just keywords.
Let's dig into that splitting part, or chunking, for a second, because this is absolutely critical to get right. The simple way is to just, cut the text every 1,000 characters. That's fixed size chunking. But a much smarter way is semantic chunking, which actually uses an AI model to find natural breakpoints in the text based on topic changes. So why does this matter so much? Well, if you split a really important sentence right down the middle, your AI is only ever going to find half the answer. Getting your chunking strategy right is key to retrieving complete, coherent ideas.
All right, now for step 3. This is where the magic really happens. We've stocked the library, we've created the card catalog. This is the moment a user asks a question and our whole system just springs to life, finds the perfect reference, and writes a brilliant, context-aware answer.
So here's that core loop, visualized. It starts when a user asks a question. The system takes that question and uses it to search our vector database, pulling out the most relevant text chunks it can find. Then it bundles the original question together with these chunks of context and passes the whole package over to the LLM to generate the final answer. Simple as that. So how do we actually tell the LLM what to do with that information? Well, we use a prompt, just like this one here from the LangChain Hub. And look at how explicit it is. It says, use the following pieces of retrieved context, and then this part is so important. If you don't know the answer, just say that you don't know. That little instruction is what prevents the model from making stuff up. It's a key piece of prompt engineering that makes the whole system trustworthy.
So at this point, we've built a basic RAG app. And you know what? It's pretty good, but it's not great. For a real production-ready application that you can count on to deliver high-quality answers every single time, we need to level up and add a few more sophisticated techniques into our pipeline.
First up, query transformation. Think about it. Sometimes the way a user asks a question isn't actually the best way to search for an answer. This technique uses another LLM to rewrite the user's query before we even start searching. It might break a really complex question into a few smaller ones, or just rephrase it to be clearer. It's all about making sure we start our search with the best possible chance of success.
Next up is re-ranking. Okay, so that initial vector search is really fast, but it's not always perfect. Re-ranking adds a powerful quality control step. We take the top, say, 10 results from that initial search, and then we use a second, more powerful model to carefully reevaluate and reorder them. It's like having an expert librarian double-check the search results to make sure only the absolute best, most relevant documents make it to the final LLM. Okay, let's just compare these two approaches side by side. On the left, you've got our simple, basic RAG architecture. It works, but on the right, you see a true production-grade system. Look at the upgrades we've made. We're using that smart semantic chunking. We fine-tuned our embedding model on our own data so it really understands our lingo. And we've even added an abstract-first search that can quickly scan summaries. Every single one of these pieces adds another layer of intelligence and dramatically boosts the quality of the final answer. Building this app is a fantastic accomplishment, but you have to remember, it's really just the beginning. To actually succeed out there in the real world, we need to think bigger. We need to think about the entire life cycle of our RAG application, from the first line of code to deployment and everything that comes after. And that brings us to the full life cycle, or what a lot of people are calling LMOps. This is what separates a prototype from a real product. We need to be constantly evaluating the quality of our answers, maybe using MLflow to track everything. We need to be monitoring its performance out in production. And we absolutely need strong governance for our data and models, which is where something like Unity Catalog really shines. It's about having a true platform that integrates all these pieces, making sure our app stays robust, secure, and reliable over time. We have covered a ton of ground here, from the absolute basics of RAG to the advanced techniques that make an application truly production-ready. At the end of the day, RAG isn't just another AI technique. It's a way to unlock the massive amount of collective knowledge that's already sitting inside your organization, turning all those static documents into a dynamic, intelligent conversation. Your data already holds the answers. The only question left is, how will you ask the right questions?